Welcome to our presentation on machine translation. Have you ever wondered how Google Translate or chatbots understand and convert languages seamlessly? Let's dive into the fascinating world of machine translation and explore its evolution, challenges, and future. Before we dive into machine translation, let's first understand NLP, or natural language processing. NLP is a branch of artificial intelligence that enables computers to understand, interpret, and generate human language. It's what powers voice assistants like Siri and Alexa, chatbots that assist you online, sentiment analysis tools that gauge opinions, and of course, translation systems. Essentially, NLP bridges the gap between human communication and machine understanding, making interactions with technology feel more natural. Now, let's talk about machine translation. It is a subfield of NLP that focuses on automatically translating text from one language to another. Some of the most popular examples include Google Translate, DeepL, and Bing Translator. These tools have transformed the way we communicate across borders. For instance, if someone types hello in English, a machine translation system can instantly convert it into bonjour in French or namaste in Hindi. But how does this work? Let's explore the different types of machine translation techniques. Over time, different approaches have been developed to improve translation accuracy. The three main types are rule-based machine translation, RBMT, statistical machine translation, SMT, and neural machine translation, NMT. Each method has played a crucial role in advancing language translation technology. Let's start with rule-based machine translation, or RBMT. This method relies on predefined linguistic rules and dictionaries to convert text from one language to another. It performs word-to-word mappings, morphological analysis to understand word structures, semantic analysis to maintain meaning in translation. For example, if we translate "the boy eats an apple" into French, RBMT converts it into "le garçon mange une pomme." While it can produce grammatically correct sentences, RBMT struggles with flexibility and idiomatic expressions. Next, we have statistical machine translation, or SMT. Unlike RBMT, which relies on rules, SMT predicts the best translation using probability-based models. It examines massive bilingual datasets and translates phrases rather than individual words. For example, if the phrase "good morning" appears next to "buongiorno" in Italian 85% of the time, the SMT model assumes "buongiorno" is the most accurate translation. While SMT improved translation fluency, it still lacked deep understanding of sentence structure. The most advanced method today is neural machine translation, or NMT. This approach uses artificial neural networks to learn from large datasets, enabling more fluent and natural translations. Unlike RBMT and SMT, NMT doesn't translate word by word, it understands entire sentences in context, leading to more accurate and meaningful translations. This is the technology used by modern systems like Google Translate and DeepL, and it continues to evolve. But how does neural machine translation actually work? Let's break it down step by step. First, the input text is broken into numerical vector embeddings. Next, the words are converted into numerical representations that the machine can process. Then, the system focuses on keywords that are essential for accurate translation. Finally, it generates the translated output in a fluent and natural manner. By continuously learning from new data, NMT improves over time, making translations more precise and contextually relevant. Machine translation is everywhere. Here are some of its real-world applications. Google Translate helps users instantly translate text, speech, and even images. Chatbots and virtual assistants provide multilingual support for businesses. Subtitles in different languages allow global audiences to enjoy movies and series. Companies use translation tools to facilitate international business and negotiations. Without machine translation, global communication would be far more challenging. Despite its advancements, machine translation still faces several challenges. Context understanding is tricky. Words like bank can mean a financial institution or the side of a river. Idioms and slang often don't translate well. For example, break a leg should mean good luck, not a real injury. Low-resource languages have limited data, making accurate translation difficult. Some translations still result in funny or confusing errors. Like the sign in China that translated "Beware of slipping into slip and fall down carefully," definitely not the intended message. While machine translation has come a long way, these issues remind us that human translators are still needed in many cases. So, what's next for machine translation? Future advancements will include better context awareness using AI to understand sentences more accurately. Multimodal translation, where text, images, and voice are all translated together. Support for rare languages, ensuring that no language is left behind. More natural and human-like translations, reducing errors and improving fluency. With continued innovation, machine translation will break even more language barriers in the years to come. To sum it up, machine translation is revolutionizing global communication. Neural machine translation is the most advanced but still evolving. With AI-driven improvements, the future holds even more accurate and seamless translations. Language should never be a barrier, and machine translation is making that possible. Thank you for watching. Or as we say in different languages. Dhanyavad. Merci. Gracias. Arigato. Danke. We hope you enjoyed this journey into the world of machine translation.